In this video, let's look at sets don't allow duplicates, but why do we still have them? So here you can see I'm creating a variable for emails. This variable is going to have the set date type. You can tell it's a set date type because it starts off with these curly braces or curly brackets either end. And then you can see we have comma separated values. So here you can see customer A, customer B, and customer A again. And then we are simply going to print the emails variable over here. And when we print this, you can see that we've got customer A, customer B, and customer A again. This one is the incorrect one. It shouldn't appear, but it does in a sec. The reason this happens is because customer A over here versus customer A over here is pretty much the same to a human eye. So here we can see that the customer A has a capital A while customer A here has a lowercase a. So essentially we are storing the emails in a set, which is over here. So there's the email variable and we've created a set over here, but sets remove exact duplicates only. And here we can see that the customer A over here and the customer A over here are not exact duplicates because of the capital letters. So customer A and customer A are not the same. So these two are not same values for the set to consider them as duplicates. So what we need to do is normalize the data before adding it to the set. So what we should do is normalize the emails like this. So that's a new variable I'm creating here. And what we are going to use is, again, we are creating a new set over here because of the curly brackets. And you can see over here, we've got email, which is the variable that comes from emails. So we've got emails, and what we're going to do is we're going to loop through and extract each of these emails. This is a variable. You can call it whatever you want, but I've decided to call it email. So we're going to change the email to lowercase and store it back in a set. Now, once they change to lowercase, then this email and this email will match. So by putting them in a set, it will remove the duplicates. And then finally, we will print our normalized emails. So if I run this code over here, you can see that we get customer B and customer A only, whereas previously we've got customer A, customer B, customer A. So what we did was convert emails to lowercase, and now our duplicates are removed correctly. So as you can see here, there are no duplicates, only unique values. So just remember, sets will allow duplicates even though they appear same to the human eye, but in fact they are unique. So make sure you normalize your data before putting them into a set so that it removes duplicates for you. In this video, let's look at sets don't allow duplicates, but why do we still have them? So here you can see I'm creating a variable for emails. This variable is going to have the set date type. You can tell it's a set date type because it starts off with these curly braces or curly brackets either end. And then you can see we have comma separated values. So here you can see customer A, customer B, and customer A again. And then we are simply going to print the emails variable over here. And when we print this, you can see that we've got customer A, customer B, and customer A again. This one is the incorrect one. It shouldn't appear, but it does in a sec. The reason this happens is because customer A over here versus customer A over here is pretty much the same to a human eye. So here we can see that the customer A has a capital A while customer A here has a lowercase a. So essentially we are storing the emails in a set, which is over here. So there's the email variable and we've created a set over here, but sets remove exact duplicates only. And here we can see that the customer A over here and the customer A over here are not exact duplicates because of the capital letters. So customer A and customer A are not the same. So these two are not same values for the set to consider them as duplicates. So what we need to do is normalize the data before adding it to the set. So what we should do is normalize the emails like this. So that's a new variable I'm creating here. And what we are going to use is, again, we are creating a new set over here because of the curly brackets. And you can see over here, we've got email, which is the variable that comes from emails. So we've got emails, and what we're going to do is we're going to loop through and extract each of these emails. This is a variable. You can call it whatever you want, font, but I've decided to call it email. So we're going to change the email to lowercase and store it back in a set. Now, once they change to lowercase, then this email and this email will match. So by putting them in a set, it will remove the duplicates. And then finally, we will print our normalized emails. So if I run this code over here, you can see that we get customer B and customer A only, whereas previously we've got customer A, customer B, customer A. So what we did was convert emails to lowercase. And now our duplicates are removed correctly. So as you can see here, there are no duplicates, only unique values. So just remember, sets will allow duplicates even though they appear same to the human eye, but in fact they are unique. So make sure you normalize your data before putting them into a set so that it removes duplicates for you. Let's have a look at printing without a print statement in Python. So here you can see that I am in a Jupyter notebook, and when I run this code over here, it's only going to print the last expression in each cell. So what I mean by that is, if I run this code, you can see that we have two variables here. And then I don't use the print statement. Instead, I just put the names of the variables here. This is going to then print only the last one, which is Spain. But France is not being printed from the variable A. So important thing to understand with Jupyter notebooks is this is a cell, and then you can have another cell. So you can have another cell in here. And if I copy this code over here into another cell like this, then I swap the order. So I do B and A, then this time it will print France rather than Spain because this is the last expression in this cell. So if I run this, you can see now we've got the output of France rather than Spain. So important thing to remember is last expression in each cell is auto displayed. This is the behavior of Jupyter Notebook. So this is a cell-based interactive Python environment. This happened because each cell acts like its own mini REPL environment. So basically, it's an interactive environment that always prints the last expression. So here, this cell is its own mini REPL environment. But this sort of thing doesn't work in the Python script. And for example, if I were to run this over here, then you can see that the output that we get is blank. So it doesn't actually print anything in this environment. So you'd have to specifically use a print statement like this. And then if I were to run this again, you can see that now it prints Spain. But I had to explicitly say that. But I can use multiple print statements here. So I can do print, and you can see now both are printed, France and Spain. Whereas in Jupyter Notebook, what you had is it automatically displays the last expression only. So it only displays, for example, here A, which is France, and here you can see each expression is evaluated, but the results are discarded unless you print them. So here B is discarded and the results are not shown, and only A is shown. So this behavior is intentional. It keeps the REPL environment uncluttered. So here you only see the last output. If you printed every single output, then this will look quite messy. So as we saw, when you compare it to the script file, which is over here, print.py, you have to explicitly use the print statement, because by default, if you don't use the print statement, so if you leave this out, then it won't actually print anything. So nothing is printed at all in a Python script file. So you might be wondering, can I print Spain and France at the same time? So can I have them both? Yes, you can. You can put them on one line as a tuple. So what I mean by that is you can do open bracket here and then comma and then B, and do it in this fashion. And then if I run this, you can see now we have France and Spain printed at the same time. So just use a tuple, so two parentheses and then a comma, and that will print a number of items that you want to print. And remember, this is an intentional behavior of REPL. So this is by design, it's not by mistake. So this is what you need to remember. This is how it's supposed to work. But use a tuple to get your two variables printed at the same time rather than using a print statement. As you saw in my previous video, that the last expression in a cell is auto displayed in a Jupyter notebook or a Python notebook. So here you can see that I have two variables, A and B. And when I just add the variable names to a blank line over here, you can see A and B, but only B is being printed. So B over here is being printed because B is equal to Spain. So how do you print multiple items in this notebook? So let's say I also wanted France to be printed. How do you do that? There are two ways to do this. One, which is you could put them in a tuple. So what I mean by that is you put them next to each other. So if I delete that and add in A and then comma and B. This is known as a tuple. So Python will consider this as one expression or one statement. So when you run this, you can see now we get the output of France and Spain like this. The alternative way is you explicitly print. So here, rather than just adding the variable name and running your code like this and I'm going to print wherever you want, what you can do is you can do the print statement and then use the variable name like this, and this will print what you want. And then you can comma separate them. So you just add B, for example, here, and this will print France and Spain. Notice that by adding a comma, it automatically adds a space in between. So you don't need to explicitly add a space. Now, if you were to concatenate them like this, so if you were to use plus, then what you'll notice is that it doesn't add a space between A and B. Instead, it joins them together. But if you use a comma, then it will add a space here for you. Again, there's nothing stopping you using multiple print statements on separate lines. So you can then do print B like this, and you can then see the two outputs, France and Spain, printed at the same time. So just remember there are multiple ways of doing it. One, which is you can of course then use this method, which is print Spain again. So you will print, you can see that it prints A and B, and then you've got A being printed here as well again. One thing that I want you to pay attention to, that this A that's being printed, it has the quotation mark, single quote. This is to denote that it's a string, while the print statement here doesn't actually have single quote. So this is how it works. So if you were to just do like B, you can see that it has quotation marks, but if as soon as you put print statement around it like this, then you can see that it actually removes the quotation marks and prints. With this method, if you do it like this, A and B, and as you can see, it will only print the last expression. So last expression of the cell is printed. This is as part of Jupyter Notebook, cell-based. So these are individual cells over here that have play button next to them, and each cell acts as its own mini REPL environment. So basically, what I mean by that is it will read the expression, execute it, print it, and then loop back and do the same thing again and again. Let's talk about the underscore variable in the REPL environment in Python. So REPL environment in Python stands for read, execute, print, and loop. So basically, it's like a calculator. So how do you access this environment? So here in VS Code, all I've done is brought up the terminal. You can bring it up by just creating a .py file here if you want, or you could go to view and then click on terminal, and this is the shortcut for it. So here, what you can do is it will automatically, if you have a virtual environment, it will take you to a venv environment. But what you can do is you can then type in Python. So here I've typed in Python and now I'm going to press enter. As soon as you do this, what you will see is that you are now in a Python environment. And the way you can tell you are in the Python environment or the REPL Python environment is you've got these three more than characters. So the more than symbol on your keyboard, or the three arrows here pointing towards the right. Now here, this environment acts like a calculator. So what you can do is, for example, if I do 1 + 1, then this will give you the answer 2. But what you can do then is use the underscore variable here to see the last result. So what you can essentially do is I bring the underscore here and press enter, and you can see the last result of the calculator was 2. So then you can do interesting things like this, but you can do underscore + 1. And this will now add 1 to the previous result. So underscore + 1, underscore contains the previous result. Just as on a calculator, you always have the last result. This is the same behavior. So what Python does is in the Python REPL environment or the interactive Python environment, it automatically stores the last result of an evaluated expression. So what we mean by that is this is an expression 1 + 1. So it will evaluate that. It will basically run that and give you the answer of 2. It will store that 2 into this special variable called underscore. So it will automatically do that. You don't need to do anything additional. And then you can access that last variable just by using an underscore, just as we did here. So we did underscore + 1. So 2 + 1, which gives you the answer of 3. So then you can do it even further. So now the latest one is stored. So 3, if I do 3 + 3 or 3 + 7, so that would give us an answer of 10. So if I run this, we should get the answer of 10. And there you are. We did get the answer of 10. So essentially, this makes the REPL environment act like a calculator so that you can just continue to use this. So now I can just do that + 1, and then I get 11. There is one important caveat though that you need to be aware of. If you use the print statement, it basically returns none. So if, for example, you do this, the underscore in IPython is a very useful helper. So let's demonstrate the underscore and its purpose in IPython, which is interactive Python. IPython is an enhanced interactive Python environment. So it basically has, you can see that you get line numbers like this. So this is in 1. So this is command 1. So for example, I can do 1 + 1 and then press enter. And for the first input line here, you get an output line of 1, and this is the answer. And for same fashion, for line number 2, you could do this, and then you will get the answer, which is 4 over here. But one thing that you can do is you can access the previous item by entering an underscore. So if I do that, you can see that it brings the previous value over here, which is mentioned there. So then you can do things like underscore +1, and that gives you the answer 5 over here. So what it does is it gives you the most recent result. So here you can see when I did the underscore, it gave us 4. When I did it over here, then 4 + 1, that gives you 5. So it's like a calculator that you can use. And remember, calculators remember the last answer. By using 2 underscores, you can access the second to last result. So here, for example, if I do 1 + 3, then that gives you 4. If I do 2 + 5, that gives you 7. So what I want to do is, rather than access the 7 here, I want to access the 4 there. So I want to do 4 + 5. So what I can do is I can do underscore to access this 4, and then I want to do +5 to that. So then I can do plus over here, and then underscore. So that'll take me back 3 values, and that gives me an answer of 9. So you can see here, the 2 underscores took me back to the 4, 3 underscores took me back to 5. So you can see the maths is all done with underscores here. Underscore is a special variable. So as I said, you can use 2 underscores or 3 underscores to access the last result. So as I mentioned, you can access the third to last result by using 3 underscores. But it is intended for interactive exploration only. So really you shouldn't use it for production code, but it's a very useful tool to access. And the final thing I want to show you is you can also access a particular result. So if you want to access, for example, the statement here of 2, then you can access it by typing it out and in square brackets, put in the output number that you want, and then we will get the answer 2 over here. And same, you can do it with in as well. So here you can see in, and it gave us 1 + 1. In this video, I'm going to explain to you how to access IPython and how is it different. So here you can see IPython is basically an interactive Python shell. It replaces the Python prompt. So what I mean by that is, so if I go over here, and as you can see, if I type in Python over here and press enter, this will take you to the Python prompt. So here you can see the 3 arrows pointing towards the right. That's your Python prompt. So you are now in Python. In order to exit this environment, what you need to do is type in exit, open parentheses, close parentheses, and press exit. So you are now on the PowerShell prompt. You are no longer in the Python prompt. So if you want to go back to Python, and you see that, and you can see you are now in the Python. But how do you access IPython? So if we try and type IPython here, and you can see that you will simply get an error. This is because you are trying to run IPython within Python, which is not possible. So what you need to do is exit out of Python. The reason you can tell you're in Python prompt is because of these 3 greater than arrows pointing towards the right. So I'm going to now exit this by typing in the exit command and press enter. So now to access IPython, you just type I and then Python. And then you can just press enter, and this will now take you to the IPython prompt. So it has now replaced the Python prompt. So you had, remember, this was the Python prompt over here with the arrows. So when you have these arrows, you are in the Python prompt. But when you have this one, like in statement here with a sort of a line number, then you are essentially in the interactive Python shell. So now you can do things such as this, and that will give you an answer there. So you type in the command and you immediately get a response. So this is faster feedback while learning. So essentially you can type in a command and get immediate answer back. And you can see it's a bit more helpful as well. It's got the line numbers in here. So that's the in statement, and that's what the output is. So you can see here, it is same as Python, but with better tools. So it's same as this Python over here. but IPython gives you better tools such as line numbers, and you can see in green is your in statement, so that's what you input, and out in what Python gives you back. IPython results appear automatically. So let's get started with IPython. In the PowerShell window here, then I'm going to type in IPython. So if I run this command, you can see that now I am in the IPython environment. You can see this is an enhanced interactive Python. So this is like the standard Python without the I. So if you were to remove I from this Python, then you would go into the standard Python. So with IPython, you do not need print statement. So print statement is not needed to see your results. This is one of the advantages with IPython. So here, for example, I can type in a number 1 plus 2. And that gives you the output immediately in 3. So I did not have to print or declare a variable with IPython. The result actually of the last statement is stored in an underscore. So I can type in an underscore here and then run this again, and you can see the output of the last result. So here you can see the last expression shows the output. So here for this one, the last expression we ran 1 plus 2, this gave us an output of 3 without the need of a print statement. Output is always labeled in this format, out and then a number. So here you can see for when we did the 1 plus 2, it said this is input number 1, and the output for that number 1 is here, out 1. So it's always in this format. So then you got the answer of 3. If you look at the second one, we did an input of just an underscore, which is a special variable in IPython that always stores the result of the last statement that was run, which was this one. So that's why this 3 is stored in a variable called underscore. And when you do print the underscore, you get the output over here of 3. You can access your historic commands by pressing the up arrow on your keyboard. So here, for example, I can access the historic commands just by pressing the up arrow on my keyboard. So you can see this was the underscore I used here, but I can also get back to this one, 1 plus 2, by just pressing up arrow again. So the up arrow will show me my previous commands. So here I can get the up arrow and see that same value that I entered there. And then I can press the down arrow to go down, up and down the commands I have typed in. So here what I can do is I can edit the numbers. So these ones that I typed in, I could access it using the up arrow. So here you can see I have edited the numbers. Previously it was 1 plus 2. Now I've changed it to 1 plus 3. So if I press enter now, and you can see the output is shown immediately over here. So to see a result, you just press enter and your results appear. No need for a print statement. So I'll show you another one. I could do 5 plus 5, and that gives you 10. So I just have to press enter to get the output of that. And then I can scroll up and down the past commands by just pressing the up and down arrow keys on the keyboard. IPython has a built-in help function. So what you can do is, in order to access IPython, you need to type in this command in your PowerShell environment or any other terminal environment you're in. So this should be recognized by your system as long as you've got Python installed. Now you can see when you type the command in, you are in the Python environment. So if you note here, this is an interactive Python environment, and you can tell you're in it because you will see this line in statement over here with a 1 over here. So you now know you are in IPython. You can exit this environment and go back to PowerShell by just typing in exit, and then you have to type in open parentheses, close parentheses. So that's your exit function, and then you can just press enter. And this will take you back out of the interactive Python environment back into PowerShell. So in order to access it again, you can just type in IPython again and then press enter, and notice that there's some text around version and so on. And then here it's ready to input your commands. So one of the things you can do is add a question mark to see the help. So here, what you can do is type in a question mark, and then you will see help appear. So here, as soon as you typed in a question mark, then you've got a lot of information around getting help. So what you can do here is keep pressing the enter key on your keyboard, and then you'll see that it will scroll through and show you all the help over here. So you can see the different bits here, the things around I've shown you previously around the underscores, when are they used, and so on, auto parentheses, and so on. The other thing you can do here is if you don't type a command in, you see the line number never changes. But if I type in and I want help with the length function, so I add in mem, we have question mark. So this again is the question mark coming in, and it will show the help. So if I press enter there, you can see that I now have help on the length function. So here it says what type is it. So type is that it's a built-in function or method, and it returns a number of items in a container. So if you give it a container, then it will give you what's the length of the container, such as arrays or lists. So this works on functions and objects. So essentially we run this question mark on the length function, but you can do it on other things, such as you can do it on the list here. So if I type in the list command, this is the date type in Python, and you can see that we now get that this type is actually a type because it's the data type or a data structure in Python. And you can see here, so it says if no argument is given, the constructor creates a new empty list, and then you can give other information such as on int. So if I type in int and question mark, you can see that int is number of users. So here int is here, and then there's also int date type over here, and then subclasses of int are boolean, because boolean, although it's 1 and 0, is based of type int. So that's why you see that here. So you can read about a few things here. Convert here, the conversion function. So if you use int like this, then it converts number if it was a string. If you pass it an empty string, then it will return 0. So if we were to test this out, then just type in int, and then you can see that in fact it does return 0 as per the help indicated here. And one good thing is no internet connection is needed for this help. If you are traveling or you're on train or plane, you can still access help offline and read the documentation. As you place functions, objects, wherever that you need, just add the question mark and you're all sorted.